Hello everyone, we are continuing the dots series. So dots is a plugin for Rhino Grasshopper. It's written in C#. You can just download it from the GitHub page. You can download the zip folder and then you can extract the zip folder. So we have already downloaded and extracted in the previous video. So once we extract the files, we should get example files, and the other important thing is dots-project.gha. The dots-project.gha is the main executable that you can directly drag and drop into your canvas, and it will install dots for you. Since we already have it, we are not installing it. So once dots is installed, it's going to display this tab with all the components of dots, and we have many example files along with inputs. So we'll look at some of the examples and we will construct a simple example today. Let's go to the Rhino files in example files, and you can see the place. So we are going to open test floor plan.3dm. So once we open the file, we can see that we have a variety of shapes that are going to be our site or a floor plate, and we're going to subdivide it along the periphery and along the internal region, and probably we can also put a mask to see that it works as a site plan. So now in Grasshopper, we go to dots, we go to general partition explorer, we pick up parcels by let's pick up peripheral subdivision parcels. Okay, we have set up the default values for wherever possible, especially for numerical and boolean values, where they appear in each of the components. So for instance, you can see when I place my mouse on top of setback dimension, it shows that one locally defined value, and the value is 1. Okay, so what we don't have is a side curve, and it says that input side curve and empty curve parameter. So empty curve parameter means we need a curve. So let's connect it to one of the curves. Let's do a simple circle first, and when we connect it to the side curve, we see that the component has changed color to gray, which means that it has accepted and it has generated some of these curves. So let's go through the component and how it behaves one by one. So I'm going to pull up a number slider by double clicking on the canvas, and I do a 1 less than 50. So this is a value between 1 and 50, and I'm going to connect it to setback. Let me just copy the same value by Control-C, Control-V. I mean the same slider with Control-C, Control-V, and so we need 4 of them, one for setback, bay depth, inner curve, and number of divisions that we need. So let's tweak the setback dimension. So the idea of dots is that we can apply the same logic as far as possible. So we try to generalize the same logic as far as possible. So in terms of a site, this is we need a setback, but if it was a floor plan, then this would have been the outer circulation around the spaces, and we can see that we are starting to generate spaces along the bay. So the central ring forms the spaces, and the inner and outer offsets from there are basically the circulation spaces or setbacks or some sort of requirements. So we can minimize them, we can minimize these dimensions, or we can just leave it at some distance to understand how it works. Now we can also take the same component system, and we can plug in the inner curve here to just get a recursively we get the solution. But what we want to do first of all is to show that we split up the output also. So if we switch off the component, which is switch off the preview of the component, and we do let's do a geometry. So I'll double click on the canvas and type GEO, and I get geometry. So this connects to the bay, and we do a number of inner curve, and finally parcel curves. Okay, so when we click on this component, so now our main component, which is parcels, peripheral subdivision parcels, is now switched off. That is, the preview is off, and we are just extracting the components. We are just extracting the output of the components. The outputs are separately organized. So from setback we get the setback curve. Okay, from the bay we get the inner bay depth, and then we get the inner curve, which is the final offset from the system, and finally we get the parcels. So each of the parcels are actually different. So we can see that there are 17 different parcels, and we can extract them in various ways that we will see in the future tutorials. But first let's look at the internal subdivision of this zone of the inner curve. So we are going to subdivide this inner curve. Okay, let's eliminate these for now. Okay, let's just keep the parcel curve and the inner curve. Okay, so for inner curve I still go to my dots, and we can go to the pick up this one, parcels by subdivision, and once again we can connect the geometry there, or we can also directly connect the input side to the inner curve. Okay, and once again we have default values set. So let's change a few of these values. Okay, so let's change the number of parcels first, and you can see that it has subdivided the parcels, and let's do 0.0. let's change the angle. So it says here angle of alignment degrees 0 to 360. So that's the angle that we are going to change, and you can see that it's turning it around. So we don't actually need to do 0 to 360. If we do 0 to 90, we should get a large variation. I'm also going to switch off this component, keeping only the output parcel from the required solutions. So we switch this off as well, so we get a clean geometry here. Now what we want to do, even though we have these parcels, we need to generate a circulation layer. So let's do that by going to space allocation and generate circulation. So in dots we go to the space allocation tab, and we generate circulation from there, and we connect this to CBSP curve. CBSP curve is the partition curves. We can take the street center lines and connect it to partition lines, and this side curve. So the outer side curve, which connects to input side, we connect that to this side boundary. Finally, we connect a circulation depth, and then the component gets activated. So we have to change it to a rational limit. Let's make it 5.0. And finally we take the geometry. So resultant CBSP. So CBSP stands for constrained binary space partition. So we have a CBSP input, and then we get a CBSP output. So now if we switch off the component again, we can see that we are getting the geometry, and once again it's giving us 11 geometries. Okay, so let's place, so this could be a floor plan like before, but let's think of it in terms of a site plan. So let's say we want to put a whole bunch of blocks inside the CBSP curve. So let's switch that off, and we connect it to our massing component. So this component is right here, massing extrude block. Okay. So we connect it there, and once again we can change the number. So for instance, if we put a setback, if we can change the setback now, and you can see that from this curve it's changing the setback. So let's also change the circulation depth a little bit. So you can see that it automatically adjusts to the circulation depth. From the massing component we get the floor curves and also the B depth. So let's switch off the massing and let's examine the output this way. So we are getting a 70 values, that is all the floor plates have been generated. So to check, let's do a list item to check. Okay, list item, let's do a 0 to 70. So we should get only the exact index of the particular item. So convert that into a vrep. Okay. So this will be a flatten list. So it's a list of lists, and we just flatten it, and you can see that it's going through all the floor plate curves. So in this way we can just extract the curve that we want. But for now, let's put the massing on the peripheral spaces. Okay, let's do a different massing on the peripheral spaces. Let's go to dots, massing, and let's pick up the courtyard massing. Okay, so now this is the parcel curve. We are going to connect that to the side curve. So we make that the side curve, and let's do a slider 1 less than, let's say, 25. So let that be our bay depth. Okay, and you can see that you've got the bay depth, and just like the extrusion, we can do a geometry of B depth and the floor curves. Okay, so we get the outer floor curves in this case. Okay, so we can switch off this component, switch off this component, and we will get the floor curves. So let's pick this up when we come back in the next video. Thank you.